Howdy, folks. Esterlin here, and we are actually doing a video today because I kind of wanted to talk about a couple of updates. One of the updates is been kind of meh here and there, kind of figuring out what's going on and so on and so forth, medical wise, and the whole shebang. And second of all, we are working on a new project, and that new project is called TIC 403027066, yada yada yada. Basically, it's a binary star system that was discovered by a amateur team, specifically our group, and basically we found out that this little guy right here, which is actually an M-dwarf star, I don't know why it looks like a brown dwarf, but it does, is orbiting an F-type star, which is a much more massive type, specifically like an F-subgiant star. Is more evolved in the evolutionary stage of stars. So basically, after G, you get F, and then after F, you get something else I can't remember. GFK stars, I think is what you call it. What's really neat about this is that this is actually discovered via the transit method. So the transit method is basically you're looking at a star's overall brightness, and that brightness is dimmed by the object orbiting. In this case, it's this star, or TIC 403027066A. That's the actual companion that is hosting or blocking the light of this primary star. And what's really cool is we're in VR. And I'm actually going to show you a little thing on the transit method that you can actually kind of do and that I think is really neat. So we're going to click here. We're going to go to motion. We're going to scroll down all the way down here until we see normalized light curve. We're going to click graph. Okay, now that we got that graph there, now, one of the things that we're actually interested in this curve here is the overall time that's passed versus the overall brightness that has actually dropped. So we're gonna slow down time, and maybe about 53 minutes or so. Okay, we're gonna fast forward it, and we're just gonna watch. Okay, so you can see this thing coming in is dropping a specific time frame, and now it's just about egress, and there it goes. It's just exiting this view. What's cool is that the egress is actually the exit phase of where the eclipsing binary is, and in this case, from our point of view, this is actually just passing out in front of our star. When it crosses in the middle of the star, we actually see it as a dip in brightness in the middle. So that's technically what's called a mid-transit. This right here is called the ingress. So when it enters our field of view, actually we're going to simulate that a little bit. So when it gets into the ingress, it's kind of interesting how it actually starts to dim. So we're going to go and slow down time again and just let it do its thing. All right, it's starting. And I'm going to pause it. Right there. This is where the star is actually entering our point of view, and we are seeing this actually from a ground-based telescope. So as we are looking at this object, we are looking at the overall star drop in brightness. We can actually see this and model this and actually figure out what type of object this is, and in this case, we actually discovered it to be a binary, and I actually thought that was really cool. And another thing that's really cool is watch what happens here. I'm going to show you what it looks like in the middle. And right now it's mid-transit, so the star is crossing in front of the primary star, and is aligned in a way where it's blocking it's totally eclipsing almost in a sense you would say, but by blocking only a percentage of light. In this case, it's about 6.5% starlight, I think, was the max drop. And then it goes into egress phase at now. So that was actually perfectly timed, not gonna lie. As the egress phase happens, we start noticing a sharp increase in the brightness back to normal, brightness modulation, etc. What's interesting about this star is that this actually seems to be a potentially magnetically chromospheric active star, meaning that this star's atmosphere is very active in star spots and as well as solar flare activity, as well as this star. So we kind of get interesting looking light curves besides these right here that you see here. Now, in an example like this one right here was actually submitted by one of our members that we've been doing on the paper. We actually found out that this was actually a potential dark spot. So basically, it's like a patch of like dark areas, kind of like how our sun does with the activity on the surface of the star. Basically, traverses across the entire area, and you can actually see it as like an extra dip. So that extra dip actually kind of can and will potentially lead to misclassification of this particular object. So yeah, this is something that we're working on, and if you actually would like to be a part of this project, we are actually almost slated to be released for publishing soon. I still have to go through more intense peer review, but this is actually starting to become a reality, at least data-wise. So I thought I figured I'd share this information with you. I thought it was interesting how we came to find it. And if you would like to learn more about the method that we use and so on and so forth, I'm probably going to be hosting more videos like this in the future in VR. So, um, I am currently looking to expand my content further. So if you want to, please feel free to subscribe. And I actually hope you found this interesting. If you did, feel free to share it with someone who actually enjoys this type of content. And, I hope you learned a little bit about this particular project. So, see you guys.